You know, it's kind of funny. Some of the most powerful ideas in all of science, the things that literally run our modern world, are actually incredibly simple. And that brings us to what we're talking about today, a tiny little concept with a truly massive impact.
So, let me just throw a question at you. Think about a satellite, millions of miles away in deep space. How in the world does it know the exact direction to point its antenna to beam information back to us on Earth? I mean, there's no Google Maps out there, right? Well, the answer is this unbelievably elegant idea that we're going to break down right now. To even start to answer that, we first have to get our heads around how we describe things that have both a size and a direction. It's just not enough to say the wind is blowing, you got to know which way it's blowing. That difference is everything.
And that's where these two key ideas come in, scalars and vectors. Now, a scalar, super simple. It's just a number, 30 degrees Celsius, 60 miles an hour. It tells you how much. But a vector? A vector gives you the whole story. It's got the how much and the which way. So it's not just a speed of 60 miles an hour, it's a velocity of 60 miles an hour north. See the difference? It's a complete instruction.
So really, the best way to picture a vector is just to think of an arrow. Simple as that. The length of the arrow, that's its magnitude. You know, how strong it is, how fast it's going, and whichever way the arrow is pointing, well, that's its direction. Magnitude and direction all wrapped up together in one neat little package.
Okay, so vectors are great. They give us both pieces of the puzzle. But what if we don't need both? What if all we care about is the direction? What if we want to know which way, and we don't care at all about how far or how fast?
And that's the big challenge, right? We need some kind of tool, like a mathematical compass that can point in any direction we want, but its own size doesn't get in the way and mess with our calculations. How do we create something that is just pure, 100% direction?
And here it is. This is our hero, the unit vector. And the solution is just so beautifully simple. We make a special vector whose length, its magnitude, is always, always, always exactly 1. That's it. Its entire reason for being is just to point.
This is it. This number, right here, this is the unit vector's superpower, 1. By forcing the length to be 1, we get rid of all the other information. We're not talking about miles or newtons of force or anything else. It's just 1, a universal standard. This one simple rule creates the absolute perfect pointer.
So how do you make one? Well, it's basically a simple 3-step recipe. You can start with any old vector you want. Let's say it represents going 10 miles northeast. First, you figure out its length. In this case, that's easy. It's 10. Then, you just divide the whole vector by that number. And what do you get? A brand new vector that still points perfectly northeast, but now its length is exactly 1. You've just boiled it down to its pure directional soul.
Trick. This idea of a pure direction pointer is honestly one of the most fundamental building blocks in all of science and technology. The impact this tiny thing has is, well, it's absolutely huge. And you see these things everywhere. Physicists use them to define the direction of forces like gravity and electromagnetism. Every realistic video game you play, every CGI movie you watch, they are using literally billions of unit vectors to calculate how light needs to bounce off of every surface. And that satellite we talked about at the beginning, yep, it uses unit vectors to know exactly where to point. Same goes for self-driving cars, for drones, for robots. It is the universal language of direction. I absolutely love this quote because it just nails it. Think about it. If the laws of physics are like a book that describes how our universe works, then unit vectors are the letters of the alphabet. They are the most basic, fundamental pieces we use to write down and make sense of reality itself. It's that big a deal. So, when you boil it all down, what's the big takeaway? Why does this one little idea matter so much? Well, it all comes down to having a common language. The unit vector is basically a universal compass. It means an engineer in Tokyo and a scientist in Argentina can talk about the exact same direction, and there's zero confusion. By stripping away the magnitude, by making that length just 1, we created a pure standard language for direction that works for anything, anywhere in the universe. So next time you see an amazing special effect in a movie or you hear about a rover landing on another planet, you'll know that the quiet, unsung hero of that story was this beautiful, simple idea, a tiny little arrow with a length of 1 pointing the way. And it really makes you wonder, right? If this is the basic alphabet of direction, what incredible news stories have we not even written yet? What new worlds are out there, just waiting for us to point the way?